Welcome to the first part of the skeletal system PowerPoint. In this PowerPoint, we're going to talk about bone tissue, the different parts of the bones, parts of the bone tissue, and also different fractures and how a fracture heals. The skeletal system in general is used to support and protect, provide body movement. It aids in blood cell formation, particularly in the bone marrow, which is going to be in either the end of the bone or the shaft of the bone. And it also creates both red and white blood cells. Storage of inorganic materials such as salt, calcium, and potassium. And we call bone tissue, more specifically, osseous tissue. The skeletal system actually has 206 bones in an adult. When a child is born, or when a baby is born, they're actually born with many more than 206 bones, about 300 to be exact. Over time, those bones fuse together and make the 206 bones that we know today. There are two main divisions of the skeletal system. The first is the axial, which contains the skull. It contains the thoracic cage and the vertebral column. The next is the appendicular, which contains the pectoral girdle, which is technically your shoulder and your collarbone, the arms and the hands, and then you have your pelvic girdle along with your legs and your feet. This diagram just denotes what the axial skeleton is. You can see here that there is a skull. There is the vertebral cage right here, and in the back, down the back, is the vertebral column. The vertebral column also goes into the sacrum, which we'll get into later, and then the coccyx, which is your tailbone.
Real quick before you record now.
This diagram just shows you what the appendicular skeleton is. So here we have the collarbone along with the shoulder, which makes up the pectoral girdle. Then you have the arms along with the hands and the wrist. And then you have the pelvic girdle right here, which is your pelvic bones, along with the legs and your feet. Like we said before, the axial skeleton is the head, neck, and trunk. It also includes something called the hyoid bone. Now, the hyoid bone is actually interesting because there's no where the hyoid bone actually connects to any other bone in the body. It's actually attached to the body via muscles and tendons. And what it does is it helps hold the tongue in place. We'll get into more of the axial skeleton after we go over bone tissue. This is just a picture of what the hyoid bone looks like. And then here's the appendicular skeleton. Once again, you have your pectoral girdle and your pelvic girdle. Now, long bones. Really quickly, let me just go over the fact that there are different types of bones. There's short bones, like your carpals. There's irregular bones, which really don't have a shape like your vertebrae. Then you have your flat bones, which are found in your skull. And then you have a long bone. The long bone has a couple different parts. The first part here is the epiphysis or epiphysis. So this is basically the expanded end of the bone. Now, there's a couple things that happen here. The epiphysis also has this cartilage on the end. And this cartilage allows other bones, such as that make up the kneecap, allow the bones to freely move over each other. So that's just basically hyaline cartilage on the end. In the center here is different types of bone called spongy bone. And inside there is where your red marrow is going to be. In the center we have something called the diaphysis or the diaphysis. Diaphysis is basically the shaft of the bone, and it has a couple different parts. On the outside of this bone is a tough membrane called the periosteum. Now, I talked about really quickly the spongy bone. Spongy bone is just like we say it is. It's spongy. If you think about what a sponge looks like, it has little holes in it. Well, you can see here that there's little penny points all the way up here in the epiphysis. Now, in the diaphysis, you're going to have your compact bone, which is really, really obviously compact, and it's very, very strong. This is where your yellow marrow, which is going to contain fat and also white blood cells, this is where this is contained. Now, going back to the epiphysis and the diaphysis. The diaphysis has something in the center. Right here you can see the hollowed out thing right there. That's called the medullary cavity. Now the medullary cavity has a membrane that makes it an outline of it, and that's called the endosteum. And then on top of that, you can start to see here a little bit of this yellow marrow. And once again, that's containing fat, and that's also containing your white blood cells. Now, the other thing that I want to talk to you about is this line right here. The line right there, we call this the epiphyseal line, we call this the epiphyseal plate, we call this the epiphyseal disc. Bottom line is they all mean the same thing. It's basically your growth plate. So what happens here is you have all these little, a line or a disc of cartilage cells. And as they mature, they're going to give rise to new bone cells. And that's going to allow the bone to actually grow in length. Okay? If you were to break a bone along this line, that could be detrimental to how much your bone actually grows. Okay? I love this diagram because what happens is you can start to see a little bit of what the inner workings of the spongy bone would look like. And you can see when we go over the different bone tissue that the spongy bone is much more porous than the other bone tissue type. Okay, inside the long bone. Once again, I did talk to you about the medullary cavity, which is basically the hollow chamber, which is going to be filled with your yellow bone marrow. This is found in the diaphysis, or the diaphysis. Red marrow is going to be found in the epiphysis, and it's going to give rise to your red blood cells. And then, once again, the endosteum is just the medullary cavity. This just shows you a look closer at what the two different types of bone tissue look like. This is your spongy bone right here. You can see once again there's a lot of different holes. It's not as strong as your compact bone, which is very, very, very tightly put together. So let's talk a little bit about your makeup of bone tissue. Now, in the tissue chapter, we did talk about lamellae. Lamellae is basically your layers of bone matrix. We talked about if you cut an onion and you have those layers there, this is kind of what it looks like if you were to look at bone tissue underneath the microscope. It looks like the layers of an onion. That's your lamellae. This is the physical place where the bone cells live. Now your bone cells here are, the mature bone cells are called osteocytes. And they are enclosed in little shells or little chambers called lacunae. Now, the lamellae are going to form layers around this central or Haversian canal. Now remember that I said Haversian canal, osteonic canal, central canal. They all mean the same thing. It's basically a passageway for blood vessels and nerves. Now, because the osteocytes right here are hardwired in the lamellae, you don't actually have a way for them to get nutrients other than those canals that we talked about that are called the canaliculi. Remember, don't say canaliculi. That's weird. Canaliculi. And they are canals that allow nutrients to travel to and from the cells. So that's how the bone cells get their nutrients. Once again, this picture, I love it because you see that this is a long bone. And then what we do is we take a little chunk out here and then we blow it up here to see what it looks like underneath. So here is an osteon, here is an osteon, here is an osteon. And these little rings all the way around are your lamellae. So here's the lamellae. These are your osteocytes in the lacunae. And then you have these little lines right here that are connecting those two that are called the canaliculi. And in the center right here is your central canal that allows for blood vessels and nerves to pass. Okay, bone development and growth. Basically, there's two different types of bone development and growth. One is called intramembranous bones, and that's basically for your flat and your skull bones. And then the endochondral is for all other bones, like your vertebrae, it's for your arms, your legs, whatever. Basically, what you need to know is that all bones eventually initially start out as hyaline cartilage, and the areas gradually turn to bone. You'll see on the next diagram that they have something called a primary ossification center. And ossification means that just cartilage is now turning to bone. So you can see here, what we did talk about before is all bones are going to have an ossification center or an epiphyseal disc. And this is your growth plate. It's basically just a band of cartilage between an epiphysis and a diaphysis in a long bone. And what happens is these areas are going to increase bone length as the bone cells ossify. One quick note that I want to make is that if you're ever on Jeopardy and they ask you what is the last bone in the body to ossify, you should tell them that's the xiphoid process, which is the tip of the sternum. Okay, give a shout out to me. All right, cartilage. Your cartilage cells, which are probably going to be hyaline cartilage, are originally going to become osteoblasts, which are basically immature bone cells. And then as they become more mature, they're going to get to be officially bone cells, which are osteocytes. You can see here this blue, that is your epiphyseal disc or your epiphyseal plate. Here's another growth plate. So you have them all throughout. And once this is gone, that means the bone is not going to grow in length anymore. This is a really cool picture. This basically shows a fetus or a baby, unborn baby, and what it shows here is that all this white, which you can actually see on a sonogram, and I'll try to show you when pictures of my kids when they were obviously in utero, you could see the white on a sonogram is actually the bone, and then these little blue areas right here are all cartilage. So these are all basically epiphyseal areas where are still cartilage and they're still growing. This is just another picture of how it starts out as hyaline cartilage, which is the blue, and here you have your ossification center, and as it grows, you start to see how the bone actually grows in length. Here's that epiphyseal disc that we talked about before. Okay, this is just another picture of bone growth. In the embryo, a young person, much like, a 4-year-old like Aubrey, this is how her bones would look underneath, if you were to split them open. And then obviously here is your adult bone. You don't see that blue disc here because they have completely turned to bone. This just shows you all the bones of the body, which we'll go over in class. And then now we have broken bones. There's a couple of different ways to look at bones here. Okay, you have a closed fracture. If something is a closed fracture, what that means is that it has not pierced the skin. An open fracture here, you can start to see that it's actually piercing the skin and breaking through. So fractures actually have a couple different terms to them. It can be either closed or open. And then it could be something like a multiple fracture. So it could be an open multiple fracture, meaning that one of the parts of the bone has actually broken through the skin, but it's also been broken in many different parts. So a multiple fracture is just obviously that the bone has been broken in different parts. A comminuted means it's almost like a crushing injury, where the bone is actually broken into tiny, tiny little parts. Here we have a green stick fracture. Green stick fractures tend to happen in younger kids because their bones are really, really resilient and they're not going to break through the whole way. So you can see here that this bone is not completely broken. A spiral injury, that's not fun. Basically what happens is it's a twisting of the bone and it's breaking it in a spiral pattern. Okay, this slide is basically just showing you again that there's a green stick, and you can see here that it's not completely broken through. Then you have here a fissure. A fissure is almost like that hairline fracture because it's just a part of the bone. It's not the whole bone. So in a sense, it's almost kind of like a green stick, but the other thing is that it's also in a longitudinal plane. Here's that comminuted that I talked to you about before, and the comminuted is that's just a crushing injury. A couple different other fracture types. You have that spiral, which is basically a twisting injury. An oblique, just like the oblique cut that we learned in chapter 1, that's an oblique where it's gone at an angle. And then you have the transverse that goes all the way across. Now, the parts or the steps to healing a fracture. The first thing that you're going to see is that the osteons, those central canals, those blood vessels are going to break. And what's going to happen is you're going to get an inside blood clot. Eventually, that is going to temporarily stitch that bone together. This is called a hematoma. Okay, so the blood clot is basically a hematoma. A hematoma is going to form and basically allow the bone to kind of be stitched back, not permanently, but just temporarily. Step 2 is after the hematoma has formed, and this happens anywhere from like a couple hours after the break up to 3 weeks. You have this fibrous tissue callus. And what that is basically fibrous tissue that is going to kind of knit the bones back together. It's a temporary fix, but what's going to happen is step 3 is going to come in, and okay, step 3. What step 3 is, and it's actually step 3 and 4, is step 3 is going to allow the bone cells to replace that fibrous tissue callus, and it's going to make a bony callus. And the bony callus is actually over exaggerating the healing process. If you were to look at this underneath an x-ray, you're going to see that there's actually a bump there. And basically what the body has done is it's over compensated for the injury, and it's add more bone there. Over the next year, what's going to happen is your body is going to basically allow that break that you had to be fixed exactly like it was before you broke it.
No idea.
So what happens is you need to make sure that you don't break the bone in the same place, because if you did, it may not break in the way that nature intended it, and that could be an issue. We'll talk a little bit more about this in class. Okay, just some fun facts about bones. Bone is made of the same type of minerals as limestone. One of the things that we talked about at the beginning of the video is that babies are born with 300 bones, but as we know, they are going to ossify or completely turn to bone. So some of those individual bones that were found in a baby may just be one whole bone in an adult. This is interesting. The giraffe has the same number of bones in its neck as a human, 7 in total, but they are extremely, extremely large. I've actually seen them when I was at the Philadelphia Zoo with my kids one time, and they're huge. And then the longhorn ram can take a headbutt at 25 miles an hour. The human skull will fracture at 5 miles per hour. So just a couple fun facts about the bones. Okay, we will go over all some of the things that you need or that you need clarified in class. So please come to class with any questions, and thank you guys for viewing.